Hello, everyone. Today we're going to work on lesson 5. We're going to take the ideal gas law that we learned about last week and expand on it, including density now in our calculations. So we're going to begin by looking at a few equations that show us exactly how to kind of mesh together the ideal gas law that we learned about last week with density, mass, and volume, a topic that we learned about way back in September. So taking a look, we have pressure times volume is equal to moles times R times T. This is our original ideal gas law. What we're going to do today is we're going to just modify it slightly by first taking a look at N. If you remember, N stands for our number of moles. So moles really is mass divided by molar mass. So if we're trying to figure out the number of moles, we would take the mass of something and we would divide it by its molar mass, or its mass off of the periodic table. Well, if we take that part and we rearrange this equation by switching our volume and molar mass, we'll wind up with this equation over here on the left. Now, I want you to pay particular attention to this fraction. So here we have mass divided by volume. Well, we know this. Mass divided by volume, we learned way back in September, we called that density. So if we replace that mass over volume with density in our ideal gas law equation, we come up with this new equation that we're going to use today to solve a few problems. You'll know that you need to use this equation because the problem will either provide you with a molar mass or provide you with a density. So let's take a look at some example problems. The first example says, calculate the molar mass of an unknown gas. So in this case, we're solving for molar mass, and it tells us some more information. We have a density that is equal to 2.14 grams per liter. We have a pressure that is equal to 3.12 atm. And we have a temperature that is equal to, in this case, 85 degrees Celsius. Now, of course, we recall that whenever we're working with the ideal gas law, that we need to convert our units of temperature from Celsius to Kelvin. So I'm going to do that immediately. So to convert, we're going to do our 85 degrees Celsius plus our 273.15. And in this case, we're going to get a new temperature in Kelvin that's equal to 358.15 Kelvin. Keep in mind, the other piece of information that you always know is your value for R. The constant that we used in the ideal gas law equation, we're going to once again use in our equation with molar mass and density. So if we go back and we recall that equation that we finished on the previous slide, we have pressure times molar mass equals density times the gas constant times temperature. Well, in this case, we're looking to solve for molar mass. So we're going to get molar mass equals density times R times T divided by P. So in this case, we're solving for molar mass. We could have to solve in a different problem for one of the other variables. But in this case, we're solving for molar mass. So now I'm going to substitute into my equation. We have our density, that's 2.14 grams per liter. We have our value for R, which is 0.0821 liter atm over mole Kelvin. And we have our temperature, which is 358.15 Kelvin. All of that is over our pressure, which is 3.12 atm. and we wind up with our molar mass. So into our calculator, we're going to type, we have our 2.14 times our value for R, 0.0821, times our temperature. We converted to Kelvin, and we're going to divide that all by our pressure, which in this case is 3.12 atmospheres. So we wind up, and we're going to keep three significant figures. We wind up with a molar mass that's equal to 20.2 grams per mole. Let's go back and look at our question. So in our question, it says, calculate the molar mass of an unknown gas with a density of 2.14 grams per liter at a pressure of 3.12 atm and a temperature of 85 degrees Celsius. Now, this problem didn't ask for what that gas was, but sometimes we might come across a problem that also asks us to identify what gas it is. So in those cases, we would look at our periodic table and we would find a gas that has a molar mass of 20.2. So in this case, we might say that our gas is neon. So neon gas has a molar mass of exactly 20.2 grams per mole. Okay, let's take a look at a second problem. Okay, let's take a look at this new problem. It says, what is the density? So in this case, we're not solving for molar mass. Instead, we're solving for density. I'm just going to write out my given terms here: pressure, molar mass, density, R, and T. And of course, we always know the value for R. It's a constant, 0.0821 liter ATM over mole times Kelvin. Now, keep in mind that anytime we're using R, because we have this unit here of liter ATM per mole Kelvin, those are the only units that we can use over here. So when we read that our pressure is equal to 780.0, but the unit is millimeters of mercury, we have to immediately convert that into ATM so it meshes with our units on our universal gas constant, R. So to do this, you might recall on the very first day of this unit, I gave you a bunch of pressures that were equal to each other. I'll just rewrite that up here. So we had 1 ATM is equal to 101.325 kPa, which was equal to 760 torr, which was equal to 760 mmHg. So in this case, in order to convert the unit from mmHg, which it's in right now, into ATM, which is what it needs to be in order to use R, we're going to use those two numbers. So on top, we're going to have 1.00 ATM. And on the bottom, we're going to divide by 760 millimeters of mercury. So in this case, 780 divided by 760 turns out to be 1.03 ATM. If we continue reading the problem, it tells us that we have a temperature of 15 degrees Celsius. So once we add 15 to 273.15, we'll get 288.15. And while at first it might appear as if we have two different unknowns because it didn't tell us the molar mass, it did tell us that we're using oxygen gas. So remember that oxygen gas is O2. So if we look on the periodic table, the molar mass of oxygen is 16. So two of them is going to be 32 grams per mole. So by telling us the name of the compound, they are in fact telling us the molar mass of it. So now we're going to use that new equation that we just learned today. So we have pressure times molar mass equals density times R times T. This time we're solving for density. So our equation, when we rearrange it, is going to be pressure times molar mass divided by R times T. So I can substitute into that equation. So my pressure, 1.03 ATM times my molar mass, 32.00 grams per mole, divided by our value for R, 0.0821 liter ATM mole Kelvin, and our temperature, which in this problem is 288.15 Kelvin. Typing this into our calculator. Remember, if you have more than one number on the bottom in the denominator, like we have in this problem, you have a choice. You can either put those two numbers in parentheses, or you can remember that you're dividing by both of them. So we're going to hit divided by before we enter in each of those numbers. So on top, I'm going to type in 1.03 times 32 divided by 0.0821, and then also divided by 288.15. So I get this answer. I'm just going to pull this out so you can see what I typed into the calculator. So we wind up with an answer here of and we have three significant figures. So 1.39 grams per liter. Now, in case you don't believe me, to test out the units, we can cross out ATM and ATM. We can cross out Kelvin and Kelvin, mole and mole, and we're left with units of grams on top and liters on the bottom, or grams per liter. Okay, there are a few homework problems on ideal gas law with density. Please finish those homework problems and submit your assignment through Schoology. If you have any questions, please feel free to email me, send me a message through Schoology, or stop by office hours. Thanks, everyone. Have a great week.